Right, we're continuing with logarithms, and we're finishing up some graphing stuff. There's only one new idea in this section. It's a pretty big doozy here. Let's get started. So the first, they're just going to show you something clever to use your calculator to approximate a really difficult logarithmic equation. We're going to solve logarithmic equations later. This one, I don't know if it has a simple solution, but here's the trick. What they're going to do, they're going to take, if I can get my pen working, they're going to take both of these, the right and the left, and they're going to make them individual lines that you can put into your calculator if you've got a TI. Okay, they're just going to graph these. We saw this trick earlier where you had something where just like a logarithm equaled a number. You could make the answer a separate line. So basically what I'm saying here, not saying it very well, is where these two lines intersect. So you've graphed these two equations. Where they intersect is the solution. It's the x that would make these both true at the same time. It's the same thing you were doing when you did like a system of linear equations. You would find the intersection point to be a solution to both of them. Well, we're doing the same thing. Now, the lines are much more complicated, but where they intersect is the solution. It's the x value that would make that happen. Now, they've gone through how to graph them, and then it's going to be difficult to see where they hit. I never do this, but here's those instructions, or they'll be in the notes or the textbook. So if you were actually trying to do this, this is how to narrow in to find that point of intersection. But the point is, you're taking the two sides of the graph, you're making them individual pictures, and where they intersect is going to be the solution. So it'd be the same here. I'm not going to go through this, but you could just make this is what they're saying to do. If you make these two individual graphs, where they intersect is going to be the solution, because this is saying the two graphs equal each other. So like the two y's equal each other, it's the same thing. So you'd be finding the x value. The point of intersection would find you the x value that makes this happen. Okay, they go through transformations again. We've already done that. So this is just asking one more type of question. I'm not sure why they bring this back here. I sliced this, so maybe it would have been a more natural fit with the last section. But so just real quickly, they're asking for the vertical asymptote, but let's just take a look at what would happen. Remember, right and left happens first, so I'd be going 4 to the left. Then we do stretches or compressions. Well, this is a stretch out in front. This is a vertical stretch by a factor of 2. Now we do flips. Now it's a negative out front, so we're going to flip it down. Remember, outside is up or down. If it were there, it'd be flipping it right or left. It'd be flipping it horizontally, but it's here, so it's flipping it down, so it's flipping it vertically. And then last, we're going up 5. So if you need to check why I did this order or whatever, go back to that old video. But really, all they're asking here is what is the vertical asymptote? Well, all this other gibberish doesn't really make any difference. All we need is x plus 4 has to be greater than 0. So x has to be greater than negative 4. So if I was writing my domain, it would be negative 4 to infinity. I'm going to just put it all like we were doing the other. Range would be everything. Now, the asymptote is just going to be at that point from the domain. So it's going to be x is negative 4. Okay, now just quickly, we'd be going right 1, and we'd be going up 3. It doesn't matter that it's in the front. It's really, you could write this the same as if you added it at the back. So this is we're going right 1, up 3. That's still just a vertical translation up. Oh, they wanted the asymptote. So same thing, x minus 1 has to be greater than 0. X has to be greater than 1. So my domain would be 1 to infinity. And my asymptote is just going to be there at that 1. Range is always the same, negative infinity to infinity. Okay, now this is a pretty crazy question. Okay, so given this picture, how could we find an equation? And this is going to be pretty tough. So what we're looking for is here. So here's the basic idea. Maybe there's some kind of shift in there as well. So how are we going to do this all from this picture? Well, the first thing we're going to do, the only real certainty we can have with this crazy curving is we're going to notice that there is an asymptote here at x equals -2. So that vertical line x equals -2. So it's normally at 0. So we have shifted this asymptote 2 to the left. So here's what that tells me. The first thing I know, only from the asymptote, is that I went 2 to the left. That's 2 to the left. Now, I have an equation here, but I don't know anything about stretches. I don't know anything about up or down, and there's really no way to read that because of that weird shape of the logarithmic function. It's really difficult. So what they've done here is they've found 2 points where they're clearly crossing the graph. So 2 clear points from the graph, other than the origin, I believe. I don't think you can work that. So these are the 2 that they've found. So -1, 1, and 2, -1 to them seem to be points that clearly cross the graph. Okay, now what do? Well, we're going to create 2 versions. We've done similar ideas in the past. We're going to create 2 versions of this equation, one for each I don't know. So if we want to solve 2 I don't knows, we need 2 equations. So they put in -1, 1. So remember, this is the x and this is the y. So they've subbed it in. Now look what happens here. They've got this equation, 1 equals -a log of 1. Well, remember what log of 1 means. That's log base 10 of 1. So the answer to a log is an exponent. What exponent turns 10 into 1? Well, this worked out very conveniently because the answer to that is 0. So log base 10 of 1, the answer to that is 0, so this entire part would drop out. And actually, we're quite fortunate. That means this equation drops out the variable a, and we now know the value of k. Okay, well, if we know k, let's create a second equation with that new knowledge. So our second equation uses, which point did we use? Uses this point. We're putting 2 in for x, -1 for y. Okay, let's crunch this down. Oh, and we know k now is 1. So we crunch all of this down, start solving. We get this. Now, you could literally find this number. Log of 4 is a number. We could divide this and we'd have some decimal here for a, but higher math, they tend to just leave it there. So we know k now, we know a. We can put together our equation. Okay, this is pretty crazy. I'm going to walk through it. If you think you got it, you can pause the video. I'm going to try to show you here. The first thing I notice is that I've got this asymptote here at x equals -3. Do you agree with that? So what I'm going to do here is start to set this up. What do I have? I've got f of x equals a. Now so that has shifted it to the left 3. That's a left shift of 3 plus some k that I don't know. Now, let's take a couple of points off of here. I'm trying to think. There got to be 2 clear points. And so, what did I use here when I did this? Hold on, I'm getting lost with my numbers here. Okay, I used these. I used 4, 3, and -2, -1. Okay, so I'm trying to think which one causes something to drop out. It's this one. Okay, so you could have tried either of these and maybe you wouldn't get where you want to go. This is the one that's going to do it for us. So I'm going to plug this in. Oops, this isn't right. Hold on, sorry. I did this when I worked it myself too. Log of x plus 3 plus k. Okay, now I'm going to plug these in. I don't know a. Now, if you do the other version of this, you could still get this to work out. But here's how it gets to be really easy. We get this same trick again. If I put this point in, I get log of 1, which we just said is log base 10. How do I turn, what exponent turns 10 into 1? Well, it's 0. So that causes, if log base 1 is 0, this causes all of this to be 0. And so we know the value of k is negative 1. Okay, so that's a super important bit of information. Now let's plug it in again. Just use our other point that we read off of the chart. So 4, 3 seem to be a clear point. So I've got a log of 4 plus 3 plus, now I have my k now. It's negative 1, so I can sub it in. Okay, so if we solve this for a, we now have the 2 points. I'm going to send the negative 1 to the other side. Let me tidy up here. So I've really got log of 7, which is a number. You could turn it into the number, but we tend to leave it in higher math. So to solve this for a, if this is a number, I would divide it over to the other side. Okay, so a is 4 divided by the log of 7. Now we have everything we need. We've got k, we've got a, and so my final equation. Again, this is confusing. We do this in higher math because it's such a weird number, but you could just crunch this if you wanted to do that. So you're not working with that. If you're going on to calculus, then you probably should feel comfortable working with it like that. And k was negative 1. Okay, so one more time. We found the horizontal asymptote. That gave us the information about the shift, which allowed me to know this has got to be an x plus 3 in there because I went to the left. All right, now you could work this with any 2 points and you'd sub, like you'd do solve for a, plug it into the other one, or vice versa. But the trick they've done, it turned out if I choose this point here and I plug that in, I get a log of base 1, or log 10 of 1. And why that's important is because the answer to that log is an exponent, and the exponent is 0. So a times 0 drops out. So we solve this, we got k as 1. Now with that extra bit of information, we plug in our other point that seems to be a clear intersection point right there. Plug that in, solve for a, and even though it's a weird number, it's a number, and that allowed us to build the equation. Okay, I wish I had some more examples to show you here, but I can always do some supplemental videos with some questions from the homework.